Hello everyone. Today we are going to discuss another LeetCode problem, random pick with weight. It is the 5th June problem for the June challenge on LeetCode. And the problem says that we are given an array W of positive integers where W of I describes the weight of index I. We need to complete or write a function pick index which randomly picks an index, and the randomness is based on or is proportional to its weight. What it basically means is, if we go to the example 2, we have array or vector W with value 1 comma 3. So we need to pick an index between 0 and 1. Since the size is 2, we'll pick between 0 and 1, but the index that is picked is proportional to the weight of the in weight present at that index. So in this case we have 1 at 0th index and 3 at the first index. So we need to pick or send return the index, but that, and it should be random, but the randomness should be proportional to the weight at that index or the value of W of I. So this is the whole problem. Although we are given some extra information regarding how we are going to instantiate the class, but we should not, or we do not have to pay attention to that. At least in this problem, we just need to complete this pick index. And the approach that we are going to take today is we will be using an inbuilt function of C++ that is rand or generate random numbers, and we will be using time as the seed. So let's just get started. First of all, we will maintain another vector of the same size, and let's just call it v. Also, we will maintain a variable that is total, which will be the sum of all the weights present in at each of the indexes. So let's initialize total equal to 0, and our vector v will be having the value of total weight till that index. So I is equals to 0, I less than size, plus equals to W of I I'll explain this thing in a bit. Also, we need to put in the seed, and I'm assuming here that you are familiar with the random function, and if you're not, kindly try to get some knowledge about the random function. Basically what it does is, when we use the random function, we get a value anywhere between 0 to the maximum value that we have specified, so excluding the maximum value. So, and that is generated randomly, and for getting the value random or more random, you can say, we use time, because the time keeps on changing. So in that sense we get a random value, and this is our pick index. We have already set the seed. Now we'll directly get the value. I'll just explain in a bit what we are doing here. Okay, so what we are trying to do, we are getting we have created another vector v, and we are maintaining a variable total. So let's just take the example of this 1 comma 3. First, when we run the loop for 0th index, we will have the value of total as 1, and we will be pushing the value in vector v for the 0th index as 0, and for the second time we will have the total as 4, and we will be pushing the value as 3. Now when we generate, and so the total would, after the loop is complete would be 4. So we will be using random function and we will generate a value anywhere between 0 to 3. So if you see or observe closely, the value generated num, if it falls between the, and we are storing the total till that index in the variable v, in the vector v. So if you look closely, the value generated would be random but would also be proportional to the total or to the weight of that particular index. So in this case, if let's just say the value is generated as 2, so it is, it belongs to the index 1, or we will be returning index 1. So the chance of value to be generated between index 0 and 1 we see would be, if the value is exactly 0 then only the index 0 is returned, but otherwise for 1, 2 and 3, when the value is generated is 1, 2 or 3, we return index 1. So you see the probability of generating index 1 is higher compared to the probability of generating index 0, because the weight of index 0 is less, and although we are using the random function, we still are having it proportional to the weight of that, the value of the weight at that particular index. So this is how we are going to solve this problem, or this is the approach we have taken. So now so same way we have written the code. So if the value of v of I is greater than or even equal to the value of our number that is generated, we will return that index, but we just need to ensure that it falls between the value of v of I and the value of the previous index v of I minus 1. So in this case, if you see, the value, if we assume that the value generated was 2, so it was falling between 0 and 3. So 0 being the value of the 0th index, and 1, 2 and 3 are the values of that are within the first index. So the value generated was 2. So it was fulfilling this condition that v of I is greater than or equal to 2. So v of I, we stored 3, is greater than or equal to 2, and v of I minus 1, that was 0, is less than the value 2. So we return that index. So this is how we have solved this problem. And let's just run the code. Finished. Accepted. Cool. There's also one other approach if you want to learn, that is, instead of using the variable total, what we do is we put in the uh, we use the vector v, but we actually put in more, like we put in more space based on the weight of that index. So let's say in this case 1 comma 3, we would be using one space for index 0, and we would be using three spaces for index 1 since the value is 3. So vector v would have a size of 4, not 2, and then the random function would be used on the size of the vector v, and the whatever the index is generated from this, if random percent v dot size would be having the value of the index w, and that would return the randomly generated index that is proportional to the weight at that index. But I tried using that approach, but the problem was that since we have a very high value, or the value could go up to 10,000, it was failing on 55th case or something. So this is a better approach because we use less space and the time limit is also not exceeded. I hope you like my video, and please like, share and subscribe. Thanks for watching the video. Bye bye.